Blammo. Good. All right. So, standard form of the equation of a line. A, B, and C are constants in context. What does the word constants mean? What can A, B, and C be?
Same.
They stay the same, sure, but that's not what I'm even talking about. They're all what's when we actually do an example or a problem with this. Those are probably all, they're not variables. X and Y are variables. They're all numbers. So they're just numbers. So in context, that's what we're really talking about. All right. Now, A and B, this is not quite in the textbook, but I think it's, and I think we've actually talked, well, I'm very sure actually that we've actually talked about this word before, but to reiterate, A and B also have a special name. What are they called? The numbers in front of the variables. It's another C word. It's in your notes somewhere.
I keep on thinking constructs.
Not constructs.
Is that a word?
It is a word.
Coefficients.
Coefficients.
Oh, yeah, we were doing that.
Coefficients. Is there two words? Is there 2 words in coefficients? I mean, is there 2 F's? Anybody know?
Yeah, there's 2 F's.
Hey Siri, spell coefficients.
Coefficient. C-O.
Never mind. Yep, 2 F's.
I told you.
I said it first. Don't be hating. Coefficients. Now, X and Y also have a name. I've heard some people say it already today. What are X and Y?
Variables?
They are variables. It's after Thanksgiving. You can't even complain anymore.
They have Thanksgiving music?
There's a few songs that are Thanksgiving music, and I still maintain that Christmas music is Thanksgiving music, but that's an old debate for old days. So, moving on. So, let's do an example. Or a few examples. Write the following in standard form. So, let's do example 1 from here. I couldn't remember whether you were coming today. I'm glad you are here. Welcome. The first part of this, because Ryan's not going to be able to be here today, the first part of this is going to be recorded, so you'll be able to go back and watch the first bit of the thing. You haven't missed a ton. Some of it's been kind of review. We learned the word constants is really the only thing new that we've learned. Yay. Okay, so first example is going to be 2y equals, we are in Unit 3 by the way, true story, good job, way to be helpful, equals 3x minus 7. So we want to write this in standard form. So we need to get, so basically in basic essential plain English, what that means is, in our context here, is we want all the variables over here and we want the constant by itself. Okay? The constant by itself, and we want the variables on the other side. We also, generally speaking, don't want any fractions, which I'll show you how to get rid of those in a minute when we do an example of that. Okay, so in order to make that happen, what do we need to change about this example 1?
gotta get the 3x to the other side.
We got to get the 3x to the other side. So how would we get the 3x to the other side?
Minus 3x.
Minus 3x from both sides. That's exactly right. Now, we've already done some abstract algebra problems, so we know that the 2y and the negative 3x can't combine, so what are we going to do with those?
Right. Put them on the end.
Yeah, we're just going to stick them down next to each other, right? So we want the x first, so we're going to say negative 3x plus 2y equals negative 7. If I'm going to record this, then I'm going to upload it to YouTube to make my life easier. Sorry. Because I don't want to have to deal with, this is not my music, it's copyright, whatever. Be annoying. So, there it is, finished, done. Moving on with our life. Next example.
That's all?
Yeah, the instructions say write it in standard form, that's in standard form. We're moving on.
So you just want to get the coefficient without a variable on one side?
Yep.
Oh.
Well, it's not a coefficient if it's not if there's not a variable. The constant on one side. Okay, so next one. How about y equals negative 1/2 x plus 2. Okay. So now we want to get all the variables on one side and the constant on the other side, and we want to get rid of that fraction. So what's going to be our first step?
Subtract 1/2.
We'd add it, right? Because it's negative, right?
Can you have it to where the variables will be on the right side and the constant will be on the left side?
You can, but it's not normal.
So you can.
There are people that would count that wrong.
Okay.
We usually want it that way. So plus 1/2 x. Right. So we end up with 1/2 x.
Wait, it's a negative 1/2 x, isn't it?
No, because we added it. Because negative 1/2 plus 1/2 equals what?
Oh, it equals
0, right? Look. No. Because we're trying to get rid of this guy, right? So what's negative 1/2 plus 1/2?
0.
0, because and that's what we're having. We're doing the inverse to get rid of it. Because if we subtracted 1/2, it would be negative 1. We don't, and that wouldn't be disappeared. 0 is disappeared. Does that make sense?
Yeah, that makes sense.
Okay, good. All right, so plus y equals 2. Now we got to get rid of that 1/2. How do you think we're going to get rid of that 1/2?
Divide.
Do you divide or do you convert it into a decimal?
That's still a fraction. Decimals are still fractions.
So then you would divide it by its inverse.
You divide it by its inverse. Sure. What's the inverse of 1/2?
2/1.
2/1. So which means you multiply it by its inverse. And if we do it to one side, we got to do it to the other side. So when we clear fractions, this is what I do. Write a big bracket. And on the outside, and I'm going to use some words on this side. This problem, it's obvious, right? We're going to put a 2. But what we're putting out here is we're actually putting the least common denominator, which when we see an example in a minute with more than one fraction, that statement will make more sense. But we're sticking the least common denominator here. And then we're going to distribute that 2 on everything. So 2 times 1/2 is what?
1.
It's not 0. It does disappear, but it disappear for multiplication, which is different than disappear for
1. Oh, because the whole.
It's 1. That's right. Okay. So this one, the fraction goes away, which is what we wanted. So 2. What am I writing? Sorry. 1x. And then we've got to do 2 times y. So plus 2y.
Do you have to put the 1x or can you just put the x?
That's actually going to be what I'm going to say next. And then we do 2 times 2, which of course is 4. And then when we have 1 as a coefficient, we don't usually write that. And so our final answer is going to be x plus 2y equals 4. 2 times 2 is 4. It's like baby math, man. Does that make sense, though? Where we got it? Yeah. Jokes aside. Let's do another. Let's do an example 3. Okay. So let's do 7x equals negative 3/4 y. Ooh. Woo. Plus 1/2. So what should we do?
Add 3/4 y on both sides.
That sounds like a great idea. Going to add 3/4 y to both sides as the first step. Right. So on the left side, we end up with 7x plus 3/4 y.
So you would put it, does it matter if you put the 3/4 y in front of the 7? Or
If we want to get really technical, for standard form, it's x and then y.
okay.
Now we got to get rid of the fractions. So we're going to do a big bracket like we did before. And what I said before is going to come into play here. What is my least common denominator between 2 and 4?
2.
2 is the least common factor, but that's not actually the least common factor would be 1. But that's not what I asked. What is the least common multiple, least common denominator? So what are we? Because we got to go up instead of breaking down. So what is a multiple? To make sure we're clear, make sure we're understanding. Since multiple people said a multiple was a factor, let's think about what are the multiples of 4. What are the multiples of 4?
2.
As a factor.
2.
Factor is smaller.
Oh.
4, 8, 12, 16, 18, etc. Yes. What are the common multiples of 2? 2, 4, 6, 8, 12, 10, 12, etc. Yes?
Yeah.
Those are multiples. Factors are when we're breaking it up, making it smaller, and figuring out what multiplies to get that number. Multiples are skip counting, right? That's what we're talking about. So what is the smallest common multiple between those two?
4.
4 is the smallest. So we're going to put 4 out here.
Okay. So it should be 4 over 1, but you don't have to put the over 1, right?
Yeah, it is. Yeah. So then we're going to distribute, basically. So 4 times 7.
28.
That's true. I'm not going to write that yet because I want to make sure we understand what we're doing. In fact, I'm going to do all of the intermediate steps. Usually I skip one of them, but for this example at least, we're going to do them all. So we're going to do 4 times this guy. If your nose hurts, it's probably dry. So this is what we're doing. We're distributing that 4 on everything. And then 4 times 7x is 28x, like you already said. It's a great job. So 28x. Oh, forgot to bring down the plus. Oops. When we pre-cancel or pre-reduce here, this reduces to 1 over 1, right?
Yeah.
And then what's 1 times 3?
3.
3. So we end up with plus 3y. If we pre-reduce here, 2 goes into 4 how many times? 2 times. So we have a 1 down here and a 2 up here. What's 2 times 1?
2.
2. So there we go. How we do it? Pretty okay?
I still don't understand how is 4 least common multiple.
What are the multiples of 3? Go.
6, 9, 12, 18.
15, 18, etc. Yes? Okay, good. What are the multiples of 4?
4, 8, 12, 16, 20, 24.
What are the multiples of 2?
2, 4, 6, 8, 10.
What? Etc. Let's pick one more. What are multiples of 6?
6, 12, 18, 24, 32.
What am I doing? 24,
30,
whatever. Plenty. These are all the multiples of, well, not all. These are the first few multiples of 3. These are the first few multiples of 4. These are the first few multiples of 2. These are the first few multiples of 6, right? What is the least, or the smallest, common one between all 4 of those? What's the smallest number that's in all of those lists? 12. So the least common multiple between 3, 4, 2, and 6 is 12. So that's what we're talking about. We're talking about least common multiple.
Okay.
So like this would be the least. That's the smallest one there. Yep. Great question.
Wait, wouldn't it?
There are some smaller ones that we take if like we reduce one of these sets, but for all 4 of those, 12 is.
I thought it was 6, but then I realized the second one.
Yep, that's right. Yep, that's right. Okay, let's do a 4th example and then we'll move on in topic. Just haven't had your pizza yet. Let's do y over 12 equals 3 times x minus 2 over 4 plus, let's make it obnoxious and say 1 over 48. It's unlikely that you will see anything that's quite this obnoxious in either your homework or a quiz or a test. But for completeness sake and for making sure we get all the concepts and we're also going to see that you can do things in different orders and be happier. So what might we do first here?
You get rid of the 4, multiplying it to both sides.
Well, we can clear all the fractions first. Let's do all the fractions instead of just the 4 first.
Okay.
So we're going to do our big bracket. A big bracket. And then we want the least common multiple between 4, 12, and 48.
4.
That's the smallest common factor. Least common multiple.
12.
No.
It can't be 12 because it cannot be smaller than 48. That's the smallest thing that we can have.
It's 48.
It is 48. Because 12 and 4 both go into 48. In fact, literally 12 times 4 is 48. Look, I made something that kind of is not quite as obnoxious as it looks.
Okay.
12 goes into 48 how many times?
4.
4 times. So we're going to have 4 times y for this first bit. 4 goes into 48 how many times?
12.
12. So we're going to have 12 times 3 times x minus 2. 48 goes in 48. How many times?
2.
Lies.
1.
1. Hannah, you can't just listen to Bree. She lies to you sometimes. Plus 1 times 1. Everybody following where all that came from?
Okay. So you just take how many times the number on the outside will go into the denominator times the numerator.
Yeah, you said that backwards, but yes. What you meant is true.
So you see how many times the number on the bottom of the fraction goes into the big number that you're multiplying it by, then you get rid of the bottom number on the fraction and multiply that to the thing.
Yes. Which is what she meant to say. I assume.
Yeah.
All right, so let's start cleaning up. So we've got 4y here equals, and then 12 times 3. What's 12 times 3?
36.
36.
So you don't do the 12 to the, you don't times the 12 times the stuff in the 3 is being multiplied to.
We kind of are in a minute, because what are we about to do with that 36?
Distribute it.
Distribute it.
But you don't just distribute the 12.
You can do it in that order. You can do it like 3 times, don't write this, you can do 3 times 12x minus 24, right? You could distribute the 12. And then you distribute the 3, ended up with 36x minus, what is that, 75 minus 3, which is 72. So you can do it in that order, because when we do this in a minute, and distribute this, we're going to get the same thing.
Okay.
Because what's 36 times x?
36x.
36x. What's 36 times negative 2?
Negative
72.
Negative 72. And then we bring down our plus 1. So see, you can do it in that order if you prefer. You can actually also distribute 3 first, and you can do 12 times 3x minus 6. And then you get 36x minus 72 as well.
So it doesn't really matter.
Doesn't really matter as long as you do the steps correctly. Multiplication follows the associative property and the commutative property. You can rearrange or group it differently and get the same answer. Now what should we do?
Combine like terms.
Sure. Where are they?
Negative 7. Yeah. So it would be negative 71.
Now what should we do?
Then at 36 with 7.
Yeah, 36x. So how are we going to do that?
Subtract from.
Yeah. Well, yes. True facts. Blammo. Any questions so far, boys and girls? Everybody turn your book to page 156. Your textbook to 156. All right, so on that page, so instead of drawing this in our notes, we're just going to use the one that they have. We're going to look at the guided practice at the bottom of that page. So on page 136, they give you an example looking at what x and y intercepts are. I'm going to kind of do a super fast sketch of a graph here, just for discussion purposes. I'm going to have a graph here, my y-axis there. Whoa, doggies. I'm going to have my x-axis here, and then I'm going to plop that down somewhere. I don't even care where. This is just for discussion's sake.
Okay, do you want us to write it?
You may, if you wish. Where is the x-intercept of my multicolored graph? Not the exact number, but where?
Right there.
On the lines.
On which one?
The
horizontal line or the vertical line? The x-intercept, I said.
The negative line.
The horizontal line or the vertical line?
One that is negative.
They go positive and negative. Bad description. Try again.
Well, that one up there is positive.
My x-intercept is negative. True. That one is what you're talking about. Is that what you're saying? Yeah.
No, that one.
Lies. Where's the y-intercept?
The other.
Right there. Right? Makes sense? Fairly straightforward where what the term x and y-intercept means?
Yeah.
Right?
It's the place where they
Now, so it gives you an example and all that kind of stuff. It gives you a multiple choice thing and all that kind of stuff. So everybody look at the guided practice. So number 2, health. Find the x and y-intercepts of the graph. All that stuff. And it gives you F, G, H, and J. If you happen to watch this on YouTube and you're not one of my students, then good luck, because you're not going to have this in front of your face. But, there it is. Yeah, so what's the answer? F, G, H, or J? I'll give you a minute to look at it.
What page is this on? Let me see.
156, sir. Bottom of the page.
I know this. Wait.
So is the answer F?
No.
H.
Okay. The answer is not F. Why is it not F? Is what I heard people say no. So so F says the x-intercept is 0 and the y-intercept is 150. Let me pause my recording, that way you people at following along at home are not. Actually, no, just kidding, because the person I'm actually making this for will have a book. So just kidding. So fast forward to some amount of time. It's not F. Why is it not F?
Because there's no y-intercept.
There's no x-intercept.
Does the line, the graph line, the gym membership thing, does it cross the y-axis? Yes or the y-axis? Yes or no?
Yes.
Yes. Does it cross the x-axis? Yes or no?
No.
No. Okay. So it's not F because the x-intercept is not 0. Okay. So is it G?
No.
Okay. Why not?
Because the y-intercept's not 0.
Because the y-intercept's not 0 and the x-intercept is not 150. Is it H?
No.
No, because it's backwards. So the answer is J, because it has no x-intercept and the y-intercept is 150. Makes sense? Is it beautiful? Does it sound good?
Yeah.
Okay, so let's look at a table example. I'm going to write this one down, and we're going to do this one together. So here we go. Not necessarily. Fine. The x and y intercepts. And here's the table we're going to do. If we're very lucky, I'm going to make up something off the top of my head that actually makes sense. We shall see, though. So here we go. We're going to say the first point is 0, negative 300. And then the next point is going to be 10, negative 250. And then the next point is going to be 20, negative 200. The next point is going to be 30, negative 150. And the next one is going to be 40, negative 100. And we're going to stop it at that. That's the example in the examples in the textbook. They hold your hand a little bit more than this example does. Okay, so this example is kind of a little bit harder than the ones that are in the textbook. Kind of. Well, yeah, no, not kind of. It is. It's still not that hard, but it's harder. So we want the x-intercept and the y-intercept. They're always going to be a point. The x-intercept. All the way along the x-axis. All along that guy right there. What is y equal to?
0.
0. So the point for the x-intercept is always going to be some number 0. Right? So how is that going to change for the y-intercept?
The x is going to be 0.
The x is going to be 0. One of these two, this table directly gives us without us having to think through anything else. Which one?
The x. No, not the x. Yes, the x.
The x one is what you're saying. This one right here.
Yeah, that
What's the x-intercept of our line?
0.
No,
We
it's
don't
not.
know.
We don't know it yet. It doesn't give us that one. It does give us the y-intercept, though. What is the y-intercept of this line?
0.
You don't know.
It's right on the
Like
page.
0 and 300.
0 and you're so close. Negative 300. Negative 300, 0 is the x-intercept of this line. Now, it does not directly give us the y-intercept. We can figure it out, though. How can we figure it out?
You're graphing these?
You don't have to graph these.
Ask the teacher.
No, you look at the table and think. Are the numbers on the right-hand side, the y numbers right here, are they getting closer or further away from 0?
Closer.
They're getting closer. So we are headed in the right direction as we go down this table, right? So the y-intercept is going to be somewhere down here, right?
Yeah.
These ones on the right-hand side, the y's are changing by how much? 50. We're adding 50 each time.
50, 60.
It is going to be 60. Good job. See, look at you. We're going to ask the teacher. No, you're going to figure it out, dude, because you just did.
Is it 60?
It is 60.
I'm confused because
No, you're not. Stop it.
no, like
Go ahead.
on the x side, we're putting but with the x-intercept, we're filling in what's on the y.
True.
The y is 0.
True.
I'm confused.
How is the y-intercept?
This is which axis, sir? I'll answer that question again in a minute.
Y.
That's the y-axis.
Oh, yeah.
What is this axis right here?
X.
X-axis. If this was the line I was graphing, then you already proved to me that you know very well that the y-intercept is right there, right? Right there, at that point, right there, what is x equal to? 0. So have you answered your own question yet? Think about it. Good. 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 Now, back to your question. Why is the x-intercept 0, 60? Okay, so if we're adding 50 every time, in order to get what we have to end up getting is we have to end up getting this number and making it 0, right?
Yeah.
What do I have to add to this one to get it to be 0?
100.
I have to add 100, right? Which is how many steps? Is that, because we're only adding 50 each time. So how many steps do I have to go?
2.
2 steps. Each step over here is how many?
It's 10.
10. So 2 steps here would be plus 10 plus 10.
We're looking for the x-intercept, though.
We're looking for the y-intercept, which is where...
Oh, so 6. Okay, I get it now. Okay, so whenever y equals 0, then
What have I written? You were right to begin with. There's an error on the page.
The x-intercept.
We wrote something backwards like a long time ago.
Y-intercept be 0 and 3?
Yeah, we wrote these backwards. I don't know what I was doing. Sorry. So this should be negative 300. I don't know what I wrote, but yeah. This one would be 60, 0. Gotcha. Now I understand your confusion. There you go. So there are our answers. Makes sense to everyone?
Yeah.
Okay. Homework. Sticky note. What do you mean, aw? We've only got 3 weeks till Christmas break. We gotta be rolling. They see me rolling. They hating. Or possibly the better version of that song. They see me mowing my front lawn. Looking at me thinking I'm so wide and nerdy. If you haven't heard the Weird Al version of that song, White and Nerdy, you should totally check it out. It's quite fun. All right, so we're going to do page 159 and 160. Page 159 through 160. And we're going to do numbers. Excuse me. 14 through 22. Evens. So not even that much. Quit crying. There you go. Oh, wait, no. What time does this class end? 11:15. Oh, we're not done yet. Good. Your homework is going to be longer than that. Good. Yay. Good. I thought we were awfully short. And we're like, what is happening? The world is changing. This class is not even over yet. Your home, I'll tell you what your homework is. That way we can fill that in because I know what it's going to be now. Now it's going to be what I wanted it to be in the first place. It's like, oh, how did we get so short? Well, we're going to do 14 through 34 evens. Still not a ridiculous amount, kiddos. Calm down. Calmate. All right, let's look at another thing here.
Same lesson?
Still the same lesson. All right, we're going to do another example. That question has been asked and answered, sir.
Well, I was messing with my phone.
Good job. So proud.
Same lesson.
Graph the following using the intercepts. Example 1. 3x minus 4y equals 2. Okay, so we're gonna do a problem within a problem here because we haven't thought through how to find the intercepts from an equation yet. We already said that the x-intercept is going to be x something, x0, right? Some number, right? And we said that the y-intercept is going to be 0, y, right? We know that much. So in order to find the x-intercept, we just substitute 0 in for y. And solve. So what's negative 4 times 0?
0.
0. So we end up with 3x equals 2. What do we need? What's the last thing we need to do here to solve for x?
We would divide 3 on both sides.
Divide the 3, both sides. So the x-intercept.
So we're doing 2 problems to get the x and y thing, and like in the y problem, we're going to be getting rid of the 3x.
True facts.
Okay.
Okay, so there's the x-intercept. For the y-intercept, we're going to put a 0 in where the x is. Should have made it 12 instead of 2, then we would have had whole numbers. Oh well. Ha ha ha. Y'all have to deal with fractions. You're so sad. 3 times 0 is what?
0.
0. And then we divide by negative 4. So my y-intercept is what?
Negative 2/4. Negative 1/2.
0, negative 1/2, right? So now our instructions say to graph this using the intercept. So we're going to draw our axes on here. Please use a straight edge when you're graphing these.
How big do we have to make it?
As big as you feel like makes sense. They are your notes, sir. I'm going to, instead of counting by 1, since I've got both of my numbers are less than 1, I'm going to count by fourths. What? Is that a comical thing? What are y'all doing? Are you laughing at each other? Please use a straight edge. How much clearer can I make it? Hey. No, look here. Okay, because it was going to take longer than you sitting here waiting for whatever the heck that is, wherever the heck it was. OMG! Yeah. What is that song?
He's gonna.
Big girls don't cry. They don't cry. This is 1/4. This is 1/2. Etc. Enough to know what I'm counting by. This is 1/4. This is 1/2. This is 3/4, etc. Okay. So my x-intercept is over here at 2/3 0. Where does 2/3 fall on this graph?
2/3 like 3 to the left.
No, that'd be 3/4. But it's close to that.
What are we doing?
Where's 2/3? Where is 2/3?
Oh, 2.
Right there. Right there, he says. Right there. Is it bigger than 1/4?
Yes.
Is it bigger than 1/2?
Yes. Because it's 2/3. No. Wait.
Bigger.
2/3 also equals 4/6. Yes.
Yeah.
How many sixths are in a half? Or half?
3.
3. So 4/6 would be bigger than a half, but barely, right?
Yeah.
So 2/3. About right there. Because math. And then my y-intercept was negative 1/2. 0. So that would be like right here. And then I take my little straight edge, or my textbook that is also straight, and I connect the dots.
God, Connor. Do better.
He said the bad word.
The bad word? What are you even talking
That
about?
wasn't.
The bad word.
The bad.
Dude.
The one and only. Dude.
Dude.
That's not a.
Dudes and dudettes. Make sense? Any questions?
Dude.
You made a smiley face with your looking.
Shh. Y'all can start on your homework.
Oh.